For this video, I will be going over an example of cationic polymerization, which is simply a type of polymer addition reaction. So I will be using the example of 2-methylpropene, otherwise known as isobutylene, reacting with boron trifluorine in a trace amount of water. Only a little bit of water is needed to catalyze this reaction because once it starts, it continues. Boron trifluorine and water form a complex that looks like this, and one of the hydrogens from oxygen leaves to form a hydrogen ion, which acts as a catalyst to start the reaction. This is otherwise known as the initiation step. The alkene has electrons and the hydrogen ion wants electrons, so a pair of electrons from the pi bond come out and grab the hydrogen. The hydrogen adds to the side with more hydrogens to form the more substituted carbocation. This is otherwise known as the Markovnikov Rule. This carbocation will now begin reacting with itself in the solution to begin forming a polymer, also called the propagation or chain reaction phase. The carbocation wants electrons and the alkene has electrons, so the pi electrons come and attack the positively charged carbon, forming another carbocation that looks like this. Here the two red lines symbolize where the new isobutylene added to the original one. We can now twist the molecule to make it look simpler and appear more like a repeating pattern, which would look like this. These hydrogens here are the ones that were originally here. So to continue polymerization, another isobutylene in the solution will react with our new carbocation just like it did before. So now this carbocation is formed. This time I used blue instead of red to show the addition spot. This process would continue to eventually create a polymer that is 100 to 1,000 units long. So after the polymer is formed, the now negatively charged BF3OH, because it lost its hydrogen earlier, can now come back and halt the addition process. This is called the termination step. This happens by stealing a hydrogen from the carbocation to form a double bond and therefore satisfy the positive charge. A hydrogen can be taken from here to form a trisubstituted alkene that would look like this, or a hydrogen could be taken from here to form a disubstituted alkene that would look like this. To abbreviate the polymer formed, two lines are drawn to isolate one of the repeating units of the molecule, and an N is drawn to represent an unknown number of units that make up the polymer.